Hello friends. Now, in the last video we have discussed regarding how to draw the transition diagram. So in transition diagram we have seen that we are having different states, and one state is your initial state and one state is your final state, and there may be intermediary step based on the input state. So the finite automata can be represented by using a transition graph. In the above diagram, the machine initially starts in the starting state Q0, then it receives the input string 1. The machine changes from state 0 to state 1. So from Q0 it is going to have the transition to state number Q1, and from Q0 on receiving 0 the machine is going to the state number Q2, which is a dead state, and from Q1 receiving input 0 or 1 the machine changes its state to Q of 1. So we can say that Q0 on 1 it is going on Q1, which is final state. So as the input string start from 1, so it can have the combination of 1 0 1 0 1. So for all the input string starting from 1, so next input string may be either 1 or maybe 0. So that Q1 has made the final state. And on input string 0, so as the starting string is 1, so it should not accept all the characters, all the input string starting with 0. That's why on input string 0 we have made the transition from Q of 0 to Q of 2, which is a dead state, means there will be no transition. Further transition means the input string is starting 0 and we have reached the first state Q2, which is not a final state, means this particular input string is not accepted. That's why Q2 is made as the dead state. Now from Q0 it is going to Q of 1. So on input string 1 it is Q of 1, and from Q of 1 it can have further transition or it can go to the next transition, like that. So that's why Q of 1 we have made as the final state. So based on the input string, so the machine changes the state one state to another state. So from Q of 1 on receiving input string 0 or 1, the machine changes its state to Q of 1, which is the final state. Means the possible input string that can be generated are 10, 11, 110, 101, 111. That means all the strings start with 1. So in this way the transition diagram will be constructed. Now we are going to, this is whatever we have draw, it is based on the DFA. We have drawn the diagram of the DFA here, transition diagram of the DFA. Now we are going to draw the transition diagram of NFA, that is non-deterministic finite automata. So NFA on the input string having the combination of 0 1, and it accepts all the strings starting with 1. So NFA for the above input string same. So here, as we know that the NFA can be represented with a transition diagram. In the above diagram, the machine initially is in the starting state Q0. Then on receiving the input 1, the machine changes its state to Q of 1, and from Q of 1 on receiving input 0 or 1, the machine changes its state to Q of 1. So from Q of 1 it is going to have the same transition on Q of 1 on 0. So the possible input string that can be generated is 10, 11, 101, 111. That means all the string with all the means all the strings start with 1. So in this way, so in non-deterministic finite automata we are having this type of transition, means it is going to accept all the input string with that particular transition diagram. So NFA can be represented using a transition graph or transition diagram, So in the above diagram, the machine initially is in the start state Q0, then on receiving the input 1, the machine changes its state to Q of 1. From Q of 1, on receiving input string 0 or 1, the machine changes its state to the same state, that is Q of 1. So the possible input strings that can be generated is 1011, 110, 101, 11. That means all the strings start with 1. So in this way, the transition diagrams will be constructed based on the input string in the NFA, that is non-deterministic finite automata. Now coming to the transition table, we have just drawn the transition diagram. Now we are going to draw transition table. So transition table can be represented by a tabular form. So how to draw the transition table? So we are going to discuss that particular thing here. The transition table is nothing but it is a table. It is basically a tabular representation of transition function. It takes two arguments, a state and a symbol, and return the next state. So it is represented like column corresponds to the input symbol, rows correspond to the states, entries correspond to the next state. The start state is denoted by an arrow with no source. The accept state is denoted by a star. So the things required or whatever present in the transition table is, it is having columns and rows. So columns, they correspond to the input symbol, rows correspond to the states, and entries correspond to the next state, that is start state is denoted by an arrow with no source, and accept state is denoted by a star. So here for this particular example, we are going to draw the transition table. So the transition table for this deterministic finite automata, which is accepting all the input strings that are going to start with 0 or 1. So on Q of 0, Q0 on 0, it is going to Q of 1. Q of 1 on 1, it is going to Q of 2. So from Q of 2, if there is input string, again we are having combination of input string 0 and 1, so it is going to Q of 2. So on Q0, if the input string is having the input symbol 1, so it is going to directly come to the final state, that is Q of 2. And on Q of 1, if the input string is 0, it is going to again come to Q of 0. So this is the basically the transition diagram is there, and based on that transition diagram we have to draw the transition table. So as we know that column represent the states. So present state, next state on input string 0 means input string or input symbol 0, and next state on input symbol 1. And number of states will represent number of rows. So number of states are Q0, Q of 1 and Q of 2. So Q0 is the initial state, so that is indicated by the arrow, and Q of 2 is the final state, that's why it is indicated with that particular start symbol. So there are number 3 states are there, so Q0, Q1, Q2. So Q0, Q1, Q2 are the states which are represented in the rows, and the states from one input symbol to another input symbol. So input symbols are 2, that is 0 and 1. So we have taken the input symbol 0 and 1 in this way. So on Q of 0, if the input symbol is 0, so it is going to Q of 1, and it is going to Q of 2, and it is going to Q of 1. So like this. So on if the input string is or if the input symbol is 0, it is going to Q of 1, so it is indicated by this one. If the input string is 1, it is going to Q of 2, so Q of 2 it is indicated like this. Now coming to Q of 1. Q of 1 on 1 it is going to Q2. So Q of 1 on 1 it is going to Q2, and Q of 1 on 0 it is going to Q of 0. So Q of 1 on 0 it is going to Q of 0 like this. And on state Q2, Q2 on 0 it is going to Q2, Q2 on 1 it is going to Q of 4, Q2 on 1 it is going to Q of 2. So the number of rows and number of columns, so number of columns will be depend on input string, how many characters, mean 0 combination of characters like 0 and 1, and rows indicates number of states. So here there are 3 states, Q0, Q1 and Q2. So 3 rows are there, and input stream either maybe 0 or 1. So that's why there are 2 columns, like 3 column present state, next state on input 0, and then next state on input 1. So in this way there will be the transition table we are going to draw based on this particular. So Q of 0 on 0, Q of 1, so it is Q of 1. Q of 0 on 1 it is going to Q of 2, so Q0 on 1 it is going to Q of 2. So Q of 1 on 0, Q of 1 on 0 it is going to Q0, and Q of 1 on 1 it is going to Q2. Then we are having Q2 on 0 it is again coming to Q2, and Q2 on 1 it is going to again come to Q of 2. So in this way we are going to draw the transition table. So transition table is nothing but the table which indicates the transitions from one state to another state in the finite automata based on the input symbol. So the number of columns will be depending upon the input symbol, how many input symbols are there. So in this case there are input symbol 0 and 1. So that the columns will be present state, then next state for input 0, and next state for input 1, and rows will be number of state like Q0, Q1 and Q2. So Q0, Q1 and Q2. So in this way the transition table will be drawn, and that can be used for studying the behavior of the finite automata, how it is going to behave for the input symbols. So in this next video we are going to discuss some more examples based on the based on by using transition table and all that things, and we are going to draw transition diagram from the input string. So in this video we have drawn the table, and in the previous video we have drawn the transition diagram. So in this way the examples will be solved either by using transition table or by using transition diagram. Thank you.